Watch how a rusty nail can be made shiny. What is the layer that has been scraped away? Most metals are found in the form of oxide. The layer that has been scrapped is iron 3 oxide. What does this tell us? Most metals will react with oxygen when exposed to air. One common phenomenon is rusting. At the end of this lesson, you should be able to describe the reactivity of metals with oxygen. Metals are found in their oxide state as they react with oxygen in the air. Metals react with oxygen to form metal oxide. Using magnesium, zinc and copper, we will observe these three reactions of metals in air. Which metal do you think is most reactive? How can you describe the reactivity of metals in oxygen? The picture shows the apparatus used to investigate the reaction of metal with oxygen. The materials required are potassium 7 manganate and magnesium in powder form. The apparatus required for the experiment are Bunsen burner, boiling tube, retort stand, forceps, asbestos tray, glass wool and spatula. First, we get a clean dry boiling tube. We use a spatula to put in some potassium 7 manganate at the bottom of the tube. Fix the mouth of the boiling tube horizontally to the retort stand. Use the forceps to put a bundle of glass wool in the boiling tube carefully. The glass wool prevents spattering of potassium 7 manganate from the metal. Be careful when using glass wool, as it may cause some problems to our lungs. The powdered metal is put on an asbestos tray to protect the boiling tube from cracking. We can now start the experiment. Click the Bunsen burner to heat magnesium. When the magnesium starts to glow, the potassium 7 manganate is then heated. Drag Bunsen burner to heat up potassium 7 manganate. Oxygen gas is produced when potassium 7 manganate is heated. Magnesium gives bright light when reacting with oxygen. Magnesium reacts with oxygen to produce magnesium oxide. Click the Bunsen burner to heat zinc. When the zinc changes to yellow, drag the Bunsen burner to heat potassium 7 manganate. Zinc produces bright glow when reacting with oxygen. Zinc reacts with oxygen to produce zinc oxide. Click the Bunsen burner to heat the copper. When the copper starts to glow, drag the Bunsen burner to heat potassium 7 manganate. Copper produces only a slight glow when reacting with oxygen. Copper reacts with oxygen to produce copper 2 oxide. Compare the reactivity of metals by observing their reaction with oxygen. The observable characteristic that can justify the reactivity of metals with oxygen is the brightness of glow in the reaction. Which one do you think is the most reactive metal from the three reactions? We can conclude that magnesium is the most reactive metal because it gives the brightest glow when reacting with oxygen. How can you describe the reaction of other metals that are less reactive than zinc? The less reactive metals will produce a slight glow. The results give the following order of reactivity for the metals with oxygen. Magnesium is more reactive than zinc, is more reactive than copper.
In this experiment, you will learn the reactivity of metals with oxygen. Here are some of the materials: magnesium, aluminium, zinc, iron and copper, and potassium permanganate. These are the apparatus required for the experiment: a boiling tube, Bunsen burner, a retort stand, asbestos tray, and glass wool. Use the different metal powders and start the heating procedure by dragging the Bunsen burner. Record your observation in a data table. Table 1. Use the labels to fill Table 1 according to observation made.
Your answer is correct. Your answer is correct. Your answer is correct. Your answer is correct. Your answer is correct.
Write the word equation for all the reactions in Table 2.
That's not right. Please try again. Your answer is incorrect. This is the correct answer.
The table shows the results of the reactions of metals P, Q, R, and S with oxygen. From the table, arrange the metals with decreasing reactivity with oxygen. A. P, R, S, Q. B. P, R, Q, S. C. R, P, Q, S. D. S, Q, R, P.
Your answer is correct.
The product of the reaction of sodium metals with oxygen will produce A. Sodium hydroxide. B. Sodium carbonate. C. Sodium oxide. D. Sodium bicarbonate.
Your answer is correct.
The diagram shows the apparatus for the reaction of metals with oxygen. Which of the following metals will have the brightest glow during reaction? A. Iron. B. Zinc. C. Copper. D. Aluminum.
Your answer is correct.
Which word equation is not correct for the reaction with oxygen? A. Calcium reacts with oxygen, produces calcium oxide. B. Aluminium reacts with oxygen, produces aluminium oxide. C. Magnesium reacts with oxygen, produces magnesium oxide. D. Iron reacts with oxygen, produces iron 3 oxide and hydrogen.
Your answer is correct.
The diagram shows the apparatus to investigate the reaction of metal with oxygen. What is the purpose of potassium 7 manganate? A. To protect the metal. B. To protect the boiling tube. C. To supply hydrogen to the hot metal. D. To supply oxygen to the hot metal.
Your answer is correct.
A. According to the diagram above, what substance will you use for X? A. Potassium 7 manganate. B. State 2 observations that you can make during the reaction of zinc with oxygen. B. Zinc reacts vigorously with oxygen. Zinc burns with a bright flame. C. What change can you observe in the product from the reaction when it is cooled? C. The hot zinc oxide changes from yellow to white when cooled. D. Write a word equation to show the reaction of zinc with oxygen. D. Zinc reacts with oxygen, produces zinc oxide. E. Suggests one use of the glass wool at the mouth of the combustion tube. E. To prevent oxygen from escaping too quickly.
In this lesson, you have learned about the reactivity of metals with oxygen. See the comparison between the reactions of magnesium, zinc, and copper with oxygen. What is the product of the reactions? What are the criteria used to describe reactivity of metals with oxygen? Magnesium burns with a bright light during reaction. Zinc burns with a bright glow during reaction. Copper burns with a slight glow. Metals react at different reactivity with oxygen. The brightness of reaction is one criterion to justify the reactivity of metals with oxygen. The more reactive metals will burn more brightly compared to the less reactive metals. Magnesium will burn in air brightly to form magnesium oxide. Metals that react with oxygen will form metal oxide.
Why do potatoes turn brown when you slice them? How do you keep them from turning brown? Click the Info button to learn more. The actual mechanism that causes browning in apples and potatoes involves an enzyme called Polyphenol Oxidase, also known as tyrosinase. The browning reaction results from the oxidation of phenolic compounds in the fruit under the action of an enzyme called Polyphenol Oxidase, or PPO, which is common in plant tissues. Once you cut the potato, you open up some of the cells. The enzyme then has access to oxygen in the air and a reaction occurs, turning the potato brown. The easiest way to prevent browning is to put the sliced potato in water so that the enzyme does not have access to oxygen. You can also heat the potato to denature the enzyme. The actual mechanism that causes browning in apples and potatoes involves an enzyme called polyphenol oxidase.